Hello everyone, just going to show some basic functionality of Anaconda Code. So I'm going to use one notebook that I had on my previous post. So let me go and get that notebook right now. Yeah, so I want to have this functionality. I mean, not obviously all the post itself, but the code to be usable within Excel. Let's move back to Excel. For this, you can download Anaconda Code directly from the add-ins store. So if you don't see the add-ins, you can go here and then find more add-ins at the Microsoft App Stores. And yeah, here you just need to find Anaconda, and then you download the Anaconda toolbox, and then you here, so get it now. And then you will have to create, if you don't have an Anaconda Cloud account, you will have to create one. I have mine here, right? So yeah, no, I'm just on the free tier, but you just need this one to start creating some Anaconda Code cells. Now, Anaconda Code is using PyScript and Pyodide on the background, so this should be able to run locally. You don't need an internet connection to use this, although it asked me for an account to create these cells. But yeah, let's try to implement this notebook, and just this. Let's make this notebook in here just a function inside Anaconda. So what we want to do is infer the third percentile value based on two previous percentiles. So then what we would like to know perhaps is what is the P90. Okay, and now we're going to use the code in this notebook, hopefully also with the plot, and let's put it in Excel. So let's see how that works. Let's go to Anaconda Code. Yeah, so the first thing you need to do is to load the environment. Before loading the environment, you might want to know which packages are you going to use. So yeah, I don't need any of these other packages. So by default, so you see that this is running Pyodide here, and yeah, I just need basically NumPy, Pandas, Matplotlib, and well, all of these come by default. But this is good enough for what we need. So yeah, let me just show you how this works on the code. Now I'm going to add a new PyScript cell. Now let's just copy over the code. The first thing that we need to do is to let's just start copying this over, and then we can start linking the ranges. Okay, so I'm going to assign this variable, I'm going to assign it this range here, right? And you see that this created a reference, and then yeah, we can do the same here with this number, right? So we're just going to define b1. You can do this either interactively or just by clicking. The percentile 2 would be this one, and then the value would be this one up here. Okay, and then the unknown percentile will be this one here. Okay, good. So now we have our variables mapped to the cell to the cell ranges. Now let's copy the next one, and yeah, I don't think we need the print. If you put some print in here, what you will have it printed on this part, okay, on the logs. So yeah, well, I mean, we can just leave the print there so we can see the result. Yeah, let's copy this over as well. Yeah, let's just do these ones, this one too. Now we have all the code that we need, and we can run. So yeah, it seems like it did run, which is quite big. Yeah, here. So yeah, let's just change this value to see if there is any difference. Oh yeah, that's great. So now let's say that the unknown percentile is well, let's say that this is the P50, it's going to be the P90, and then we need to look for the P10. Okay, yeah, and that's great because now the P10 is over here. So it even changed the title of the plot. So, but yeah, I don't have the values itself. So let's see if we can fix that. I mean, the plot is cool, but I also need the values. Well, yeah, the values are here, but yeah, it's 3.2 million. But I would like to see the value, and let's create another one. How about that? Let's create another one here. I will put some new cells here and then hit save button. Okay, so now I have it. Let me just take out the decimal values. Yep, so let me just put one value that doesn't make too much sense. So let this be the P10 and I want to find P90. Yeah, well, it doesn't make sense because the P10 in my context, as we were talking about the PRMS defined reserves, well, it doesn't make sense that the P10 is less than the P50. So we can make this P50, we can make this P10, and we find the P90, and yeah, we'll have the result in here. You see, now we can change also these values to 10 million, and then the P10 will be 50 million. Yeah, so that's then the P90 will be 2 million in this case. That was a quick demo to show you how it works. Hopefully you have found this useful. And yeah, this works offline. Just remember that the code that you're using here, this code is running locally. It's not running on the cloud because it's using Pyodide, which is based on WebAssembly, and all the Python code that is running is actually running inside this, browser window. You can also check the libraries that it has. So it has some nice libraries in here. When you look at Pyodide and you see that you want to add some more libraries, you see you have a lot of them. There is a good amount of libraries that you can use. I think scikit-learn is also here. Scikit. For today, I hope you have found this useful, and let me know what uses do you have for Anaconda Code. And yes, this is pretty exciting. I mean, there's a lot of possibilities of using Anaconda Code inside Excel. Excel is naturally the most widely used data analysis tool, and is used by a lot of people that are not data scientists. To these people that want to do this kind of analysis, that want to do some plots that are not in there, they want to do some basic machine learning. So this is really, really great. The only thing that I don't know how this is working right now is where this code is hosted, because I had to create an Anaconda Cloud account to actually put this code in here. I'm not sure why is that. If Pyodide or PyScript runs locally, I don't know why do I have to put this code there. But yeah, if anyone knows, please let me know. It would be great. Let me know in the comments. And yeah, see you later.